some new whiz-bang virtual reality application where I have a huge amount of data that I want to analyze. The question is, I need a huge amount of performance, and how am I going to turn my application into performance on this heterogeneous mix of applications, of architectures. Today, if I want to do that, right, I have to deal with a variety of different programming models, right? I've got to deal with threads, or I have to deal with data parallel programming model using CUDA, or I have to develop an MPI application. And this is a nightmare for most developers, right? So I would argue that we're already specialized, and if you want to get performance out of the conventional set of architectures out there, you need to become a fairly or highly specialized expert programmer. And necessarily this will mean that there'll be a few number of programmers, and they won't be able to, the large majority of programmers will not be able to get good performance, right? So the alternative that the con side would have you believe is that maybe we can do general purpose programming and get high performance. Well, lots of people have tried this over the years, and probably people in the audience can attest to the fact that it hasn't worked very well, right? And the reason is, a couple of reasons. One, you don't have enough semantic knowledge to actually extract parallelism, especially heterogeneous parallelism. And two, the programming models are just way too general to actually be able to extract parallelism that can exploit the sorts of specialized architectures that we've argued will be the norm in the future. So the question is how we make specialized programming languages practical, because currently they're not, right? They're tied to the low-level architectures, and so what we need to do is we need to raise the abstraction level and think about domain-specific languages. So think about specialization at the application level instead of specialization down at the architecture level. So there are very good examples of this. SQL or SQL is probably the #1 parallel programming language in the world. Another example for developing scientific applications is MATLAB, which has been used extensively. If you look at the graphics arena, OpenGL has been used to enable a number of different graphics architectures to evolve over the years. So in this scenario, the idea is that application developers would combine a bunch of different domain-specific languages, and each of these would have their own specific compiler targeted at exploiting domain knowledge and parallelism to target the heterogeneous mix of architectures that we've argued is going to be the future. And in the future, and going into the future, the development of these high-performance domain-specific languages will be easier. There'll be embedded DSLs that blur the line between libraries and languages. There'll be languages that support these embedded DSLs like Scala and F#. There'll be metaprogramming techniques that can exploit domain-specific knowledge and parallelism. And there'll be frameworks that help DSL developers develop new DSLs that can target different domains. And there'll be frameworks like SpoofX for front-end syntax variations, Rose, which is making a big splash in the high-performance computing market arena, Delight, and Terra, and Lua. And so the future is domain-specific high-performance languages, and that is going to enable us to develop applications with a small amount of effort and achieve very high performance. So going forward, keep calm and vote yes.